Hey guys, this is Madan for CG Tudes Plus, and today in this tutorial we'll be seeing on how to create a cool particle disintegration effect in 3ds Max using thinking particles as our particles engine. So we'll be seeing on how to create this disintegration effect using thinking particles, and afterwards we'll be seeing on how to texture our particles to make them show up the texture in 3ds Max default scanline render, and also to texture them in Krakatoa particle render engine. So let's get started. First up, I'm going to create a thinking particles group like that, and next let's open up the properties, and what we're going to do is we're going to create uh, a new particle group that is going to get emitted using pistol shot at the 0th frame. So let's do that. First, let me go ahead and create a standard or let's create a extended primitive torus knot like that, and I'm going to move it up in the z-axis just a bit like that. Now let's go into thinking particles and create a new group and call that as static group, and we're going to create a new master dynamic set and name this as particle bond group. So let's just rename that. Now let's create a node helper and select the torus knot as the input node, and I'm going to pipe the node into a surface position helper to make the particles get bond from the surface position of this torus knot node. So let's create a new helper, the surface position helper, and also let's create a let's create a position bond operator like that, and I'm going to pump the node attribute of the node helper into the surface position helper like that, and this surface position helper is going to generate the surface position of this node, and it's going to give it through this channel, and this position channel we are going to map it into the position input of the position bond operator, and I'm going to do a pistol shot of about 1000 particles to keep everything a little bit easy on my computer, and I'm going to make the particles get bond into the static group. The lifespan is going to be something like say 500, and I'm going to zero the speed and the direction like that, and let's see what we get. And before that, let's click the master dynamic set and check edit on the fly so that we can see some real-time updates, and there we get the particles. So I'm going to hide the torus knot now, as I'm not going to need that anymore. So this is the particles that have been emitted. Next, what I'm going to do is I'm going to create a shape node, I'm going to create a cube, and that cube is going to get animated as it is being as it comes down in the z-axis from some point like 20 to 0, so that slowly these particles get engulfed into the cube, and we are going to use a condition that is the enmesh condition, and we're going to move the particles that are inside the cube into a new group called the dynamic group. So let's see what we can do now. Let's create a new group and call that as dynamic, and create a new dynamic set and call that as particle test, and I'm going to create a new condition helper or operator, and let's bring in the enmesh condition, and we are also going to need a node helper. So let's create a cube now. Go to create standard primitives and create a box, I'm going to create a box of this size like that, and I'm going to move it on top of the particles, and it's going to get animated as it is at frame 0. So at frame 0 it's going to be at some position like this, and at frame 40 or 50 something it's going to come down like that and engulf all the particles. And let's see what we've got. Okay, so this is the animation of the cube. Now let's open up thinking particles and pick the cube node. Let's make visible the node output and pump this into the InMesh node. And we are also going to need the particle position, so let's bring in the static group and expose the position. So we'll pump in the position of the particles into the InMesh node, and this is going to give a output boolean value for all the particles that are inside the cube. So we'll create a new operator, a group operator that is going to direct all the particles into the dynamic group, and we'll send the static particles over to the dynamic group. And this condition says that only the particles that are inside the cube are going to get transferred into the dynamic group. So this is going to get connected to the on input of the group operator. So let's see what we have got now. So as of now you can't see any change because there is no distinguishing between the two particle groups. So let's go into the dynamic group and change its color to something we can recognize a bit much easier, that is the red color. And just a second. Okay, so now you can see the particles that are inside the cube are turning red, and as the animation progresses, so all the particles are being transferred into the dynamic group. So that's what we are looking for. And now we are going to apply some dynamics into the dynamic group. So let's see what we can do for that. I'm going to create a new master dynamic set and call that as dynamics. We are going to create a group. We are going to bring in the dynamic group, and we'll bring in a dynamics operator, the standard force operator. And I'm going to create a new gravity force. So let's go to forces and create a gravity force like that. And I'm also going to create a wind force. So let's create a wind like that. Okay, let's rotate it about 180 degrees. Like that. And let's connect these two forces to the thinking particles node so that we can use these forces inside the thinking particles engine. So let me select the thinking particles and bring it over here, and we are going to bind to space warp like that, and also bind the wind to space warp like that. And now if we go inside the thinking particles node, we can see that the deactivate list is still empty. So all you have to do is click outside somewhere and reload the standard force. So now you get both these operators over here. So let's first activate the gravity node and see what we are getting. So let's connect these so that we get some changes. So you can see that only the particles that are red, that is the dynamic group of the particles, are being affected by gravity. So this can lead to some cool disintegration effects. I'm going to increase the effect of the gravity a bit. So let's select the gravity node and increase the strength something like 4 and see what we are getting. Okay, let's decrease that to something like 3, and now I'm going to activate the wind uh, helper, or the wind force. So let's activate that, and let's play the animation. So I'm going to increase the strength of the wind just a bit. Let's increase that to something like 5. That, and I'm gonna give it some turbulence and a frequency of something like let's say I'm gonna give it some micro frequencies. So let's try 0.1, and the scale is gonna be right. Okay, that looks better. Now what you're going to do is you're going to create a plane so that these particles colloid with the plane instead of going or dropping right down. So let's do that now. I'm going to create a U deflector. I'm sorry, I'm going to create a normal deflector of this size, and we'll also bind this deflector into the thinking particles node so that we can animate it inside thinking particles. Like that, and let's expand this a bit. Okay, now I'm going to create a new dynamic operator, that is the standard collision operator, and you can see that the deflectors have already appeared in the inactive list. So let's activate that and connect it into the particles group so that we get some nice deflections like that. So you can see right now that the bounce factor of the deflector is too high. So let's select the deflector, and I'm gonna decrease the bounce to something like 0.3 and variation to 50%, chaos to something like 30%, and let's see what we're getting. Let's hide this cube for now because we don't need that anymore. So that's the effect we are getting. I think you can decrease the effect of the wind just a bit. So nice disintegration effects. Let's decrease it even more like that. Okay, perfect. I'll try 3, and let's go and tweak the bounce factors just a bit so that we get some nice realistic collisions. And I'm gonna bring the friction up to something like 60% so that they don't just slide on the surface like that. And you can develop this idea, and instead of collapsing the particles with the gravity, you can go ahead and add some turbulence to create some nice Hollywood style apparitions or disintegration effects, so that the particles don't just fall onto the ground. Instead they just undergo some nice turbulence or vortex fields and just disappear just like that. So you can do that. So next up I'm going to create or I'm going to apply a material into these particles and see how I can render them out in the default renderer. So right now if you render it, you're going to get just a blank screen because the scanline renderer is not set up to pick up the particles from thinking particles. So we need to apply a standard shape to them. So let's see how we can do that. I'm going to create a new master dynamic set and call that as uh, the shape operator or the shape set, and I'm going to bring the all group, and I'm going to go into operators, shape, and apply standard shape to that, and connect these two particles. And let's first try a sphere. Where's that render? Yeah, let's click on render, and you can see that we are getting some nice green colored particles. But one disadvantage with applying spheres to the particles is, as you zoom in, you can see that there are no more particles, but they are large spheres. So instead of applying spheres to the shape, we can apply this constant shape. What that does is it just modifies the shape of the sphere according to the camera distance. So the farther away we are, the larger the sphere, so that we can see the particles more clearly. But as we go nearer, the smaller the spheres become. You can see that effect if you just show the mesh like that, and let's create a render. And if you go closer, you can see that the size of the sphere is this much, but if you click render, the size gets recalculated according to the camera distance, so they just become small again. So you can see that the size has decreased, so all you get is a point instead of a sphere. So this is another nice thing in picking particles. Next thing, what you're going to do is we're going to render up these particles in a color that's much different or significantly different than green color, say a texture that is mapped into the particles. So let's see how we can do that. So let's go into the shape node, and what we are going to do is this. First we are going to create or we are going to get the UVW position of the torus knot node, and we are going to apply colors to the particles according to the position where they are situated inside the torus knot. So we're going to create a node helper for that. Let's come in and create a node helper. And we are also going to need the surface position helper to get the UVW value of the surface position of the torus knot. So let's pick the torus knot. Just give it a minute to load, and okay, I've hidden the torus knot, so let's go and unhide everything. There it is. So let's select pick node and pick the torus knot, and now we can go ahead and hide it, and also hide this box. So this torus knot node attribute is going to get pumped inside the surface position node input, and it's going to give out the UVW values according to the position of the particles. So let's expose the position attribute of the particles group and pump in the position, or I'm sorry, pump in the particles into the particle input of the surface position. So now we get the UVW for each particle according to the node input. What we're going to do now is create a new text map color helper, and we're going to assign a new material, or I'm sorry, a new map. Let's apply a standard checker map for first, and let's align it according to the torus knot first. So let's unhide all, and I'm going to go to materials and apply this map into the diffuse channel, and apply this material to our torus knot like that, and show the texture. So let's hide this box like that, and let's increase the tiling of the map just a bit. Okay, I think I can keep the UV tiling at 2, so that would be nice. Perfect. So now let's hide this, and we are going to input the UVW value into the UVW attribute of the text map color, like that, and this is going to output the color value for each particle. So we are going to apply that to the standard shape vertex color. So let's expose the vertex color and connect it to the vertex color, and let's click on render. Right now you can't see any change because let's just take a look at our particle setup and see where we are going wrong. Okay, the all group is coming into the particles node, text map color. So this particle is going inside standard shape. Okay, our particle setup is right. So let's click on render, and still we are getting this green color because the entire color of the particle of the text map color is getting applied to the entire particle setup. So what we want to do is create a new material inside the standard shape helper. Let's create a standard material, and let's open up the material editor and put this material over here, and we're going to apply a new map to the material and call that as, and that map is going to be the vertex color map. So what we are telling the particles engine is we are asking it to assign individual color to individual particles so that we can truly see the text map color output inside the particles color setup. So right now if we go ahead and click render, yeah, we can see that we are just getting some black particles, but if we turn on the alpha channel, we are seeing that some particles are being colored black. So we can see that effect more clearly if we apply a different color into the if you apply a different color for the checker map and click on render, and there we can see we are getting nice particles. To see the effect more clearly, what we're going to do is we're going to increase the particles count to something like 100,000, and just give max to load all the particles. Let's give it some time. Yeah, so Max has finished loading the particles. So let's now click render, and again give it some time to render to load up all the particles. So I'll resume this video as soon as the render finishes. Okay, so here's the particles that are finished rendering. So you can see that there's not much difference between the previous frame and this frame. We're just getting the same amount of particles even though we increase the particles count to much higher value. That's because of this attribute over here. Let's decrease this to 1000. That's because of the surface position over here. What it's doing is according to the input node, it's generating a vertex value of the node, so that all the positions that are being generated are just the vertex positions of this node. So we're not going to see much of a larger difference between the previous frame and this frame, because all the extra particles are just being generated on the vertex, overlapping each other. So that's just it. So if you're going to get a nice random effect, you need to select the phase mode. So let's now increase the particle count and see what we are getting. And I'll resume the video after the render, and there you can see the final rendered image, and as you can see, it does not resemble anything to a checkered map. You just get random blue colored and red colored dots. Well, that's because of just one basic flaw in this setup. What that is we are getting the particle information, that is the particles information from the all group, and we are assigning colors to the particles vertex color using the standard shape operator. And all this we are doing that using a separate surface position helper. So this surface position helper is not the same as this surface position helper that's generating the particles at their respective positions. So both of them generate different coordinates or different particle positions for each particles. So everything is getting messed up pretty much bad. So what do we have to do that? What do we have to do for correcting that is just one simple thing. What you're going to do now is just disable this master set and go into the particle bond group, and we're going to apply color into the particle bond group. So let's now create a let's create a standard text map color, and we are going to just change this particle setup just a bit, cause what we're going to do is we're going to just let's invisible unused, and let's visible the bond particle node, and let's disconnect everything. And what we are going to do is just a little bit different from what we did before. We are going to just emit the particles at first. So all the particles are going to get emitted at the origin, and after emitting the particles we are going to change the position of the particles so that they correspond to the surface position of the node helper. So let's connect this node over here, and we are going to create a new position node, and we're going to pump the bond particle into the particle node of the position helper or the position node. And now we are going to give the position of the surface node into the position of the position helper. So what we're going to do, what we have done is in the previous setup we generated the particle position before the particles are being generated, or before the particles are being born. But in this setup we are generating the particle information after the particles have been born, and moving the particles according to the surface position node. So this will generate some good results for us now. So now let's so now in this setup we are using the same surface position helper for both the text map color and the position of the particles. So now we are not going to get much of a randomness. So I'm going to pump the UVW value of the surface position over here, and let's select this map and copy it and bring it over here. I'm just trying to bring up the material. Yeah, there we go. So let's go into this map and bring in the diffuse value over here and make that as an instance. So let's turn on preview, and let's create a new shape node or shape operator, standard shape operator, and expose the vertex color. So I'm going to connect this bond particle to the particle of the shape operator, and the vertex color to the color of the text map color, and we are going to apply this vertex color to the material node of the standard shape operator, like that, and just verify our setup. Let's see. Oh, and yeah, we need to give the particle information to the surface position helper 2 so that it generates the correct coordinates. So let's pump this bond particle into the particle group so that the correct UV coordinates are being generated. And I think that's as far as it can go. So let's try to render. Okay, so let's go to the particle node and standard shape and uh, generate a constant shape, and also up the particle count just a bit and give it a render. Okay, so you can see that we're getting some checker shape. I think let's up the particle count to see a bit much more clearly. Just give it a minute to load. So there we go. We are getting some nice checkered shapes into the particle node in thinking particles using the default scanline render. But what to do if we use Krakatoa as our particles engine? So let's quickly go ahead and change the renderer to Krakatoa, signed renderer, and there we have Krakatoa. So let's click on render right away, and you're not going to see any particles as such because Krakatoa is by default set to not recognize thinking particles in the scene. So let's activate thinking particles by clicking thinking particles node over here, and just give it some time and click render, and you're not going to see any particles. Just give it some time. Yeah, so we're not going to see any particles in the normal mode, but in the alpha mode we're going to see that the particles are in fact being colored by Krakatoa, but the only problem is there are no lights in the scene. So let's go ahead and create one, but first I'm going to go to thinking particles and decrease the particle count because it's bugging my machine too much. Even though I have an i7-2600K, I have only 4 GB of RAM, so I need to upgrade that. So that's why it's just hanging like hell. Just give it some time. Yeah, let's decrease the particle count to 1000, and there. So let's now render our setup, and we are getting just this in the alpha mode, and in the normal color mode we are not getting anything. So I'm going to create a standard spotlight target spot, like that, and I'm going to use ray trace shadows. Let's turn on the shadows. Okay, perfect. Now let's click on render, and you're seeing some nice white particles in the color mode. So let's close it and open up the render setup dialog and go into Krakatoa. So what we need to do is to send the color information of the thinking particles node or a helper into Krakatoa. We need to pipe the information through a data channel. So let's open up thinking particles, and let's up the particle count just a bit, and we're going to create a new helper, or well, I need to search where the data channel is. Yeah, here, data channel, and I'm going to pipe the Born operator into the data channel, and we're going to expose the color, and pipe this color information into the data channel, and we're going to go into the particle, or we're going to go into the the all group, and we're going to add a new data channel. So that's going to be the color data channel. And remember, we need to set the name of the data channel to the correct alphabet, so that it's going to get recognized by Krakatoa. So let's remove this data channel and put a cap C O L O R. So this is the correct format, or the correct naming convention to send the color information to Krakatoa. So let's add that for now, and let's see what we get. And there we have some nice checker textures applied to the particles. So I'm gonna go into thinking particles. Let's zoom out, go to thinking particles properties, just give it some time to load. I have it minimized. So let's increase the particle count to 100,000, and again give it some time to render, to generate all those particles. And let's click on render, or before that let's change the camera angle just a bit. Yeah, and another thing to keep in mind is make sure that you have at least 8 GBs of RAM if you're trying more than 1 million of particles. So you can see that just 100,000 is bugging my 4 GBs of RAM. So let's decrease the count to 1000, and just correct the camera angle like that. What I'm going to do is I'm going to create a new camera, because I can't adjust these things in the perspective. So let's let's create a new target camera, create, and like that. And I'm going to go switch on to the 4-view mode and set this view as the camera 1, and just move the camera so that I get some nice angles. Okay, perfect. So now let's click on render. I think we can zoom in just a bit, or instead of zooming in, I can select the camera and increase the FOV, or I'm sorry, decrease the FOV, so that we just zoom in to the camera. Just modifying the camera so that we get some nice okay, let's click on render, and I'm gonna increase the particle count. Like that, and I'm going to pause the video now and just take a quick render and resume it from there. So, oh god, just a second. Yeah, just come up. Yeah, there we go. That's the checkered map that has been rendered in Krakatoa. So instead of using the checker map, you can obviously go ahead and assign some nice material. So you can see obviously in Krakatoa all the standard materials have been blanked out because Krakatoa doesn't support standard materials in the preview window. So let's go into the maps, and instead of a checker, I'm going to apply a bitmap. So I've applied a new bitmap, and let's see how the bitmap comes up in Krakatoa. That's an image of a just tulip flowers, and you can see that it has been applied here. To see this effect a bit more clearly, we are going to apply it to a cube and see what we are getting. Yeah, let's create a standard box. Like that, and like that, and let's go into the thinking particles menu, and all we need to do is just pick up this torus knot and assign the cube over there, and it's getting just applied to one face, but let's just keep with that. Let's go up and render it. And let's up the particles count just a bit. So that's the completed render of the tulips flowers, and you can see that everything is just particles that have materials assigned to them. So that's the method of just coloring the particles, that is the thinking particles, in standard 3ds Max renderer, standard scanline render, and the Krakatoa particle render. So let's just quickly go ahead and reassign the particles to the torus knot. Just delete this cube, and go into the thinking particles, and just click the node helper. Before that, down the particle count, and click the node helper, and let's unhide all the particles, or yeah, and I'm going to select the torus knot like that, and the text map is going to be a checker, colors red and blue. We're just seeing how well our disintegration effect comes up, and tiling of 10 in the U coordinate, and give it a render. Okay, so I'm going to now create a movie of the disintegration effect and see what we get. Okay, I've gone ahead and rendered an entire sequence of the disintegration effect, and you can see that as we play back, we can get some nice disintegration effect like that. You can also see that the textures of the particles are just getting clinging onto them as if it were a camera mapped effect. So that's another nice cool feature over here, and you're getting some nice turbulence fields too because of the wind. Another effect that you can do is create a nice vortex like field
with turbulence to create a nice godly disintegration effect of some kind. I'll leave that to your experimentation. So that's it for this tutorial, and uh, we'll see again in another exacting tutorial. Until then, bye from Madan. This is Madan for CG Tunes Plus.